All right, my job today to get you ready with the last stuff you need to know for the Communication 6 test. That's the big test coming up on, I believe it's Monday. And we have been doing all these things with exponentials, which can either go this way, which is exponential what? Growth, or they can go this way, which is exponential decay, or they can go this way, which is kind of like exponential growth, and then, oh, wait a minute, it tails off like that, and that's called a something function. Basic logistic. Write that down. Basic logistic. Those are the hard kind. I've practiced this with you before, but I don't think I have a video on it. Do a one good thorough example for you. Let's say this is 0, 3. That's the starting value. They might even just say your starting value is 3, and you have to know that means 0, 3. Okay, the starting value always has an x of 0. That means like time is 0 is when you start. Then they'll have one other point, and let's say I say that the other point here, what does that look like? If that's 3, that must be like 12, so let's make that like, oh, I don't know, 4, 12. And then, if that's 12, then it looks like it maxes out at maybe 25. Okay, limit to growth. So, how do we do this? We start with the formula. The formula you start with, focus please, up here, this general direction. Some of you are looking all around the room, but you need to be looking here. Okay. You need y equals the limit, which is that goes on top. That should be 1 ax, no, a b to the x. Sorry about that. Brain lock up for a second. And this a b part we'll figure out. So right now, would you please put in the right numbers to do the start, the initial value? So would it be y equals Mr. TL over on the left-hand side. Get me started. On the top, good. Yes, and we put 0, 3, so where am I going to put the 0 and the 3? This is 3, and that's 0. All right, good start. Now solve for A. Yes. A and B. A is not just the like the growth factor, or the starting value, like it is in the theory. A and B are numbers. It looks a lot like the exponential, but I don't have great zippy names for this. Is the start, and this is the rate of growth or decay. It's not that simple. They are A and B. They are constants that you have to figure out for each problem. So they are numbers. We need to find out what those numbers are. So if you start with a 3 here, you got 3 equals 25 over 1 plus a b, or no, the b to the 0 I don't need anymore because the b to the 0 is really 1. So now this is the smart way to do it. You bring that 1 plus a up to the top, you say 3 times 1 plus a, and you do not multiply it out. I made that mistake on one of the first 2 problems I did with you, and I multiplied it out and made the problem way harder. Why not? Because you can just divide by 3 now. And now I'm almost done. 1 plus a equals 25 thirds. Notice I am not solving because you won't have a calculator on this test at all. Then, subtract 1 from both sides. And a equals 25 thirds minus 1. Now, I'd simplify that a little bit. 25 thirds would be kind of like 24 thirds, which would be 8. So that's 1/3. And I take away 1. It will be 7 1/3, or 7.3 repeating. So I'm going to round it to 7.3. Now, as soon as I do that, though, I am not using exact value because it was really... So when test says use exact values, I would have just done it wrong. Okay, you have to use exact values. You can't round it off like 7.3 repeating to 7.3. So, I'll leave it as 25 thirds minus 1. I know it looks crazy, but it's y equals... And then I have the limit on top, which is 25, over 1 plus a comes out to, in this case, 25 thirds minus 1. Whew, that's ugly. B to the x. All right, now this b I have to figure out next. It's going to be awful. Figure out the b, I'd have to put in these numbers. Now, I'm going to save us some time. I'm going to do another problem like this in a minute where the numbers work out nicer. All you need to know is that would go in there, there, and there. The 4 comma 12, that'd be a 4, that'd be a 12, and then you'd need to solve for b, and it'd be really, really ugly, but I don't want to compound the ugliness here. So we'll do another one of the ones from the worksheet together. That'll come out a little nicer at least. All right, do you get the basic process? You stick in the first point, figure out A. And then when you're done with that, you stick in the next point, figure out B. All right, we'll do another one like that in a minute. So next kind, and you have not learned this yet. This is, I start with 7 and I'm double it. Just times 2. If I go like this, that's going to keep doubling it over and over again. But the thing you haven't learned is, what if I say I'm going to double it in 3 days? How do you factor in that in 3 days part? It's really pretty simple. This is about the time here, right? Isn't that where the time goes? So if I do it in 3 days, I go like this. Let me just go back to that same slide. I'll just do it on here. Divide by 3. That would be doubling something in 3 days. Or have you ever heard of half-life, like in science? Okay. So then that would be something like this. Let's say something starts out with, I don't know, 1,000 units of carbon in it, and then its half-life was like this. If its half-life is 16, depends on the substance, if different things break down faster than others. If it's 16 hours, I just go to like this, divide by 16. And then the only thing you have to clarify is that the answer then has to be in hours. Now, can I be positive whether they're going to need you to write that or not? No, but I can tell you if you do write that, then you'll have it for sure correct. If you wrote all this out and you didn't clarify what the units is, do you get how if somebody said 14 days and 14 days to double or to do a half-life, and another kid did, oh, this is 2 weeks, so I'm going like this. You see how their answers are totally different? That need to be like one kid did it in weeks, one kid did it in days. So if I say 14 days and you did this, then I'd want you to say in weeks. And couldn't you even see somebody else saying, well, I want to do it in years? And so if it's 2 weeks, 2 weeks is a 2 out of 52 of the year. So you could even do that. I don't know. That's not any easier, but in years. All right, so let's give you one like that. See if you can do it. I think you'll find that this will be one of the easy kind of problems. So you got $60, and you've been losing money in the stock market like crazy. We can say it's in millions, so you can be someday when you're really rich. You got 60 million in the stock market, and you've been losing money pretty fast though. Thing in half every 3 years. How much money you have? It's been getting cut in half every 3 years. Write me an equation. Cutting in half every 3 years. So you'd say y equals c, and we're doing this in millions. You can cut in half. If it keeps happening over and over again, that means to the x power. And then if it's every 3 years, you're going to go like this. And then keep that from looking like it's every 3 days, you'd say in years. Raise your hand if you followed that. All right. Any questions on how to do that kind? That is a pretty simple one. The only thing that's really different is this part. And then you just clarify if they say it happens in, 23 days, then you just have to say 23, and now it's not in years, it's in days. Okay. Next is where we talk about rates of growth and decay. I know most of you would know that this is decay. Why? Because this number is smaller than 1, so you know it's going to get smaller and smaller, right? But what percent decay? And don't say 93 or off the smack yet. 7% decay. Do you get what you're really doing in your head there? You're taking 1 minus something, right? So what you should do is take these and always write them as 1 minus or 1 plus. Because if anybody ever wrote this, I would know that it's 30% growth. And that's the same as 1.3, but it separates it out. What if it's like this? That minus 0.27 really might be 0.63. But if you write the 0.63, you might think it's 60% decay, and it's not. It's 27% decay. Okay, what I'm getting at? All right, so try this one on for size. Let's say they tell you this equation. Is it growth decay? How do I know it's decay? Because the number inside the parentheses is smaller than 1. There's a decimal here, in case you didn't notice. Okay, so now, what percent decay is it? Basically, you take this away from 1, right? So if I go 1 minus, what you're saying is 90.3. Okay, 89.3. Then I'm going to see if you're right. I'm going to go like this. Is that the exact same thing as what I had before? 1 minus 0.893. Is that really 0.107? 9. Yep, it works. So, and that makes it a lot easier. Now, if you look at this, what percent decay is it? What percent decay is it? The percent decay is this. It is 89.3% decay. It is not this number. It's this number. All right, so here's another one. Typical test type question. You got 100. 1 minus, no, let's go this one. 87 dx, and you'd say, is it growth or decay? And you'd say decay, and then what percent decay? Not 87. What? 13. 13% decay. All right. Now, you write me the equation. I'll tell you a situation. You've got 10,000 walleyes in Red Lake. Now, you just caught a whole bunch of poachers who were netting walleyes and then selling them to, like, restaurants. And you can't do that unless you have a commercial license, and you really can't do that unless you have permission from the reservation, because Red Lake is mostly owned by the Indians that live on the reservation there. So let's say we take our 10,000 walleyes and we say that their population declined 0.6% based on this. All right, main equation. Assuming it kept going, you have 10,000 walleyes and the population is declining by 0.6%. Now, a lot of errors get made in the media with numbers because people don't understand them. 0.6 could mean 60%. It doesn't. In what I just said, I said 0.6%. That's different than 60%. It's not 6% either. It's 0.6%. Do you get that that's less than 1%? All right. Well, if you have 10,000 walleyes, I'm going to go 1 minus, that's a smart way to write it, 1 minus percent. If I go like, let's go down 6%. So how do I do 0.6%? 0.6. That goes down by 0.6%. All right. And then that has to be the x, otherwise we weren't doing an exponential at all. All right, so that's decreasing by 0.6%. Now, why don't you try doing it by increasing by 100%. So they got their population of walleyes to increase by 100%. Usually you can only do that by basically stopping people from fishing completely and then trying to stock the lake with extra walleyes. Usually put in walleyes that are really small, and the problem with that is everything eats them, like their little Happy Meals swimming around, and all the other fish are like, yay, free food. And a few of them survive. But so if you go up by 100%, you go on like this, 1 plus, and then what's 100%? 1. So it's the same thing as if you said 2, you're okay, or if you said 1 plus 1, that's even smarter. That's 100%. A lot of people get confused by that, and they think it's just 1, only 1. But if I just take this and multiply it by 1, it's not going to go up, is it? It's going to stay the same. That's why you need the 1 plus 1. The first one, when I multiply it by 1, it'll bring that back, plus another 1 for my increase, my 100%. All right? So now, one last question to see if you really understand. They say that really these Asian carp that are swimming in our rivers are really multiplying fast. Have you seen those videos of people water skiing and having the Asian carp jumping up behind the boat? Raise your hand if you know what I'm talking about. That's only like 7 of you. I'll show you the video in a minute here. And their population is growing dramatically. It started back in 1990 something, 98 or something. There was a huge flooded a whole bunch of ponds. And when the water receded from the flood, went back into the river, Mississippi River. And all these carp came with it. And then the carp, these Asian carp, which apparently somebody had imported because they were good at like cleaning the bottom of their fish farm or whatever. They were like, bottom feeders, and so they were kind of helpful in that little environment. Anyway, once you put them in the body of water like the Mississippi, they've been growing like crazy, and there's no way to stop them. And so they're kind of crazy fish. I'll do the video, you'll understand. All right. So if we started with 16,000 fish in a section of the river, okay, so that's our initial value. You can write me an equation for this. And we figure some way to cut down the population of these fish, and it's going to decrease the population by 0.5% per year, which is pretty depressingly slow, but you should be able to write me an exponential for that. Decreasing by 0.5% per year. 16,000 to start with. Starting value is as simple as it seems. Decreasing by 0.5%. Well, 1 minus, how many of you knew that? Okay, good. Then 0.5%. Is that 1 minus 0.05? No, that would be decreasing by 5%. So 0.5%, 0.005. Raise your hand if you had it right. Good. What am I missing? To the x. All right, good. All right, let's do one more of the kind that I just taught you. Half-life or doubling kind of a problem. Let's say that somebody figures out a really cool device like these Google glasses. It's just a pushback on the Google glasses. Have you heard about the Google glasses? You put them on, and they actually exist now. They have like 800 or 8,000, I can't remember which it was, people that they have designated as their beta testers. So they got to write an essay about why they would be the best person to test out these Google glasses, and then they got to have them. So there's people walking around with them right now. And you put them on, and basically it can be like your iPhone, connect it up to them, and then the cool part is that let's say you look at this wall over here. If there's any barcodes on the wall, it can scan the barcode so it can follow your eyes. So say I'm looking at the barcode here, it can zoom in, and on the glasses it'll register that you're looking at the barcode here, and it will then input the barcode into your iPhone and figure out what that is. Or have you seen those little QR codes that look like a barcode sort of, except you can do the QR code would be a really simple thing that your Google glasses could scan that and then read it, put it up on the screen, which is the sort of like sunglasses. It's like on the back of the sunglasses, so you can see the thing that it pulls up. So it's got potential. And one thing that people are kind of annoyed, though, there's some pushback against these Google glasses, is because they're always recording. So you could be like walk to a bar, for instance. You are recording all the people around you, and so if somebody does something really stupid, you've got a recording of it that you could put on YouTube or whatever. The thing that they don't like about it is that there's facial recognition software too, which can mean that in theory I could have Google glasses on, and if I looked at you, they could recognize, okay, I see this, I'm recognizing that face, I can search for it, I can pull up the name. Can you imagine somebody having a database so that they could walk down the street and know who you are? And if it gets deep enough, like if it gets hooked up to like a Facebook database, for instance, it could find you on Facebook, pull up your profile, and see what all your friends look like, and say, oh, I know that you know this person and that person and that person. Just think possibilities, like creepiness. So, and also possibilities for, you know, for yourself, from the person who's using it, gets a lot of good information. Like if they want to be able to, I don't know, sell you something. So Google Glasses are going to start growing here. I'm going to give you a last problem to ponder. I don't know what. Oh yeah, it is kind of, but it's totally different. Not just the fact that you can look at something and it registers and realizes what you're looking at, and then like searches. It's like it does a Google search for it. So you know that Facebook will eventually be tied into that too. So okay, let's talk about growth. Grow dramatically, and let's say that it grows, and the number of Google Glasses out there were to grow triple every 45 days. What haven't I told you is important? The starting value, very good. So let's say that they start with these 8,000. I think there was 8,000 people got them. They start with 8,000, and the number triples every. There was one, I thought it was kind of smart marketing. It was one bar in Seattle. It was officially the first bar to ban Google Glasses because their patrons thought they were too creepy, and so they got advertisement like on the whole, you know, like all of North America found out about this one bar and in their name, and that alone is worth like $500,000. But anyway, so they got noted as the first place to ban Google Glasses. Oh, we've started with 8,000. Here's my starting. And then I put growth. I could put 1 plus, but I'm just going to keep it simple. If they're tripling, I'm just going to go like this. I could say that's 1 plus 2, but I'd rather just tripling is a big old 3. And then at 345 days, I need to go like that. And then the last thing, how many of you remembered this? In days. How many of you actually remember to put in days? Very good. Okay. So that's the last practice of the new stuff. Now I'm going to hand out the worksheets. Notice I said plural. I am giving what theoretically I could be giving you one worksheet today and then one worksheet tomorrow. I'd rather give them both to you today because I talked over everything and have you practice a little bit of everything. So I'm going to just do odds on both worksheets today, and then tomorrow your assignment will be to do the evens on both worksheets. But I would recommend doing it this way. Do the odds on both of them today. Yes, sir. Nope, you cannot. You have to have the x over 45. It does affect the equation itself, so you need the x over 45 just like that. I could give you a longer explanation, but I'd rather get into some practice problems with. Lots of speculation right now about what Apple's next big product will be, and there's a lot of speculation that it's a TV because Steve Jobs, before he died, was talking about how they had finally figured out TV, and they haven't actually got it done yet, but at least back before he died, he said he had figured it out. So they're talking about integrating Siri type technology into it, so you can talk to your TV, tell it, find any, like, and I think it would be like TV stations along with internet, and it would, you could do searches that are much more broad, like, you know, find me any way I could watch episodes of The Simpsons or whatever. Say, okay, well, I got these episodes here on Netflix, or I got these episodes over here on Hulu, or you can watch it free over here on, what's it? There's another thing that's kind of like Netflix, except it's free. What's that called? It's got all the Seinfeld episodes on it. Don't know that one. So I don't think that's the one. What would you say? Yeah, was something. What did you just say? What did you just say? Yeah, I don't think. And I just heard about it today in the math office. Somebody was talking about how all the Seinfeld episodes are there and they're free. Figure out what. Okay, anyway, to the worksheet I just handed out. Let's look at the first. We're doing the odds only today. Okay, so read me number 1, please. Initial value 10. Okay. Ooh, limit to growth. That sounds like one of these kind of deals. 40. Wait a minute. Initial value was 10, so 10. Really 0, comma 10. See through what? 1, comma 20. One of those problems. These are the hardest ones, but at least this one worked out a lot nicer than the one I was showing you before. Okay, so let's do this one together. You got y equals, you got a 40 on top over 1 plus ab to the x. That's how you always start. You take your limit here, you put that on the top. Next thing, value. 10. I'll put in a 1 here and a 10 here. And I'll get 10 is 40 over 1 plus a, because the b to the 0, wait a minute, it's supposed to put in a 0 there, sorry. 0, comma 10, not 1, comma 10. All right, and then b to the 0 drops out, so now I'm down to just this. Next thing, and this is really important, I used to distribute the 10 out, and so 10 times 1 and 10 times a, that was a bad idea. It should go like this, 10 times 1 plus a equals 40. So that part goes in parentheses and gets times by that part. Here's why. Because now I can get rid of the 10 all at once. Watch what happens. Divide by 10, divide by 10, and now I don't have to divide each separately. I divide by 10 once, and now I got 1 plus a equals 4. Right? It's a lot cleaner. The other way would have worked, just slower. It's just subtracting 1, a equals 3. Yay. A is 3. That's a nice number. So I go y equals. And then my limit to growth was again 40 over 1 plus, and the a now is 3, b to the x. I'll let you solve it from there. That is the hardest. The new point now where goes in here and here. 1, 20. See if you can solve for b. That's the hard part. Now, pause for a second while you give that one a shot. Let's see how many people can do it. Okay, I'm back from the pause. I'm going to finish this puppy up. I have 20 times parentheses, a big parenthesis, all of that, 1 plus 3b to the 1. 1b, though, so I don't really need to say b to the 1. Say b. Equals 40. Why? Because what's really happening here is going this times that. It's cross multiplying. All right. Rid of that to clean it up a little bit. Now, got to get rid of the 20. Divided by 20. Again, this will make it go so much cleaner because 40 divided by 20 is just 2. And all that's left is 1 plus 3b. And then I subtract 1 from both sides. 3b equals 2 minus 1 is 1. So b must equal 1/3. Final answer then. Y equals the limit to growth. Got to keep looking back because I have Alzheimer's. 40 over the 1 plus the a we solved for was, where's the a? 3, thank you. And then the b is 1/3 to the x. And it's so easy to forget the to the x. I forgot it in my last class when I was doing this. So could happen to you too. Any questions on that? Okay, just do the odds. There'll be a couple more like that are practice. Now let's look at the other worksheet I handed out during the pause there. That's worksheet 3.2, number 1. That worksheet is easier. Number 1 there just says 3.5 times 1.09 to the x. And I'm supposed to be able to interpret from that whether that's growth or decay and what percent growth or decay it is. Well, this tells me the initial number, and it doesn't even ask for that. This tells me whether it's growth or decay. Since it's 1, it's growth. And what percent growth? This one's pretty simple. You already know the 1's right there, so it must be the rest of the... And so therefore it's growth of 9%. Let's do one that's a little harder, though. Look at number 3. Problem 3 on worksheet 3.2, number 1. 78963 is my starting number. And then that equals nope, I'm sorry, is being times by 0.9 something, 968 to the x. Now, what's the growth rate? It's not growth, it's decay, because it's less than 1. And if I were to write this as 1 minus something, what I say 1 minus 0.0232? And I'm just going to test that by adding that to this and make sure it really adds up to 1. Let me make sure. 609. Yes, it does. Okay. So therefore, its decay rate is 3.2%. Notice I moved the decimal 2 spots. Always 2 spots. Figure out my percent decimal. Okay. I think I've given you enough help. Odds on both worksheets. Still got 15, 20 minutes. No. 20, 40, 20 minutes left.